Good morning, all of you. In the last class, I given one question. You got the answer. The decrease in stopping potential is equal to, that value is equal to E into V1 minus V2. The decrease in stopping potential E into V1 minus V2. So this value is equal to 1, 1. So again, this is equal to E is equal to given E is equal to 1 electron volt. 1 electron volt. Or again, next one. Suppose here the V1 minus V2 is equal here. V1 minus V2 is equal here. So this one is equal here the 1 volt. So E into V1 minus V2 is equal to E into V1 minus V2 is equal to here the 1 electron volt. Again, V1 minus V2 is equal to 1 volt. So this is a decrease in stopping potential. Decrease in stopping potential. Right. Next question. Photoelectric emission PEE. Photoelectric emission is observed from a metallic surface for frequencies nu1 and nu2. Frequencies nu1 and nu2 of incident light in the bracket condition nu1 is greater than nu2. Nu1 is greater than nu2. If the maximum velocity of maximum values of kinetic energy of photoelectrons emitted in the two cases or in the ratio 1:9. 1:9. So 1:n. Then the threshold frequency of metallic surface is given by one application. The photoelectric effect is observed from the metallic surface. Again, here two light frequencies are given. So first frequency of light is equal to nu1 and the second light frequency is equal to nu2. So one is equal to nu1 and the second one is equal to nu2. But what is the condition is equal here? First light frequency is more than second one only here. So nu1 is greater than nu2. So nu1 is greater than nu2. If the maximum values of kinetic energy of the photoelectrons, so maximum values of the kinetic energy of the photoelectrons emitted in the two cases ratio is equal to 1:n. Maybe 1:n. So then again, what is the threshold frequency of metallic surface is given by. So what is the value of the threshold frequency of the metallic surface? Just 1 second now, think about this sum here. So what is the value of threshold frequency is equal here? Yesterday I given one application, second application also here. So what is the ratio of the kinetic energy? What is the ratio of kinetic energy? So whenever two light waves of frequencies, nu1 and nu2 incident. So what is the ratio of kinetic energy is equal to? So yesterday I told this equation here, kinetic energy Ke1 by again Ke2 is equal here. So what is that equation here? So this one is equal to nu1 minus nu0 by nu2 minus nu0. Is it given yesterday equation here? So now we have to apply this equation. So no sir, we forget this equation here. You have to do just like a general method only. Okay? Again extra 2-3 steps extra only here. Okay, in the condition here, the two light waves of frequencies are given. So one frequency is equal to nu1 and the second frequency is equal to nu2. So now again here the ratio of the kinetic energy of these two cases is equal here. The ratio of kinetic energy of these two cases is equal, this is equal to n. So Ke1 by Ke2 is equal, n is equal to given. 1 is to n is equal to given, 1 by n is equal to given, okay. So Ke1 by Ke2 is equal, 1 is to n, 1 by n. So what is the nu0 is equal to how much here? So what is that equation here? Shall I write direct equation or maybe application orientation only here? So what is that equation? Energy E is equal to what is the formula here? So energy is equal to W0 plus again Ke max, W0 plus Ke max. So energy E is equal to h nu. Since here the incident light frequency is given. So whenever incident light frequency is given means you have to use this equation. So hc by lambda only. Suppose incident light wavelength is given. So what is the formula is equal to here? hc by lambda. hc by lambda, okay. But in this question here this both frequencies are given only here. So whenever frequency given means what is that equation? h nu. So W0 is equal, what is that equation? This one is equal here this one is equal to h nu naught or maybe W also anyone, okay. Plus again Ke max. So Ke max is the kinetic energy, this is equal to Ke max. So now what is that equation here? So h nu is equal to h nu naught plus Ke max. Or Ke max is equal here so h is equal to common nu minus nu naught. So what is the ratio is equal to how much here? Ke max 1 by Ke max 2 is equal here. So Ke max by Ke max 2 is equal here. So h into nu1 minus nu0 by, so h into nu2 minus nu0. H is cancelled here. Same this equation over here. The ratio of the kinetic energy is equal here. If you know this application here, you have to save time also here. No sir, we don't know this application. Again, it will take some time only here, okay. So Ke max by Ke max 2 is equal, what is that equation here? So nu1 minus nu0 by nu2 minus nu0, okay. So now tell me here, what is the Ke max 1 by Ke max 2 is equal here? If the maximum values of kinetic energy of the photoelectron emitted in the two cases of the ratio is equal to 1:9. So this value is equal to 1 by n. 1:n. So 1:n. This value is equal to 1 by n. The ratio of the kinetic energy is equal to 1:n. So this is equal to 1 by n. So which one is equal to nu1 minus nu0 by, so nu2 minus nu0. Shall you do this remaining answers here? Okay, so what is that equation? 1 into nu2 means nu2. So minus nu0 is equal to n into nu1 minus n into nu0. So now we have to find nu0 value here. So again, we will go to this side, this become positive here. So again this is equal to negative also. So nu2 minus, so nu2 minus, so n into nu1, so which is equal to here so nu0 again minus n into nu0. Here so this nu2 minus n into nu1. N into nu1 is equal to nu0 is common here. So 1 minus n. So what is threshold frequency is equal? Nu0 is equal to. So nu2 minus nu1 by 1 minus n. Yes, please note down. So nu2 minus n into nu1 by 1 minus n. Next one. The next one. Next sum. Not done. Next sum. The energies of incident photons PHOTONs photons, not protons, photons, or 3, 4 and 5 electron volt. That energy units are given electron volt, 3, 4, and 5 electron volt. And the work function of the metals are 0.5, 2.5, suppose second 1.5, 2.5 electron volt. Then find the maximum kinetic energy of photoelectrons are in the ratio. One simple question. The energies of photons, nothing but incidental light energies are given here. So complete how many waves are there? 3 waves here. So first one is equal to 3 electron volt, second one is equal to 4 electron volt, again third one is equal to 5. So simply how many light waves are given here? 3, okay? So 3 photons are given over here. So one is equal to 3, 4, 5. And again here the work functions of the metals are. So 3 metals are given here. So one is equal to 0.5, second one is equal to 1.5, third one is equal to 2.5. So 3 different metals are given over here. So what is find the maximum kinetic energy of the photoelectrons in the ratio is equal to. So what energy equation here? Same as this previous equation. Energy E is equal to this energy E is equal W naught plus K E max. In this question here, the energy is given here and W naught is given. So you have to find out here what is the ratio of the maximum kinetic energy only. So completely how many metals are given here? So 3 metals are given over here, okay? So first point, energy E is equal to 3. So again W naught is equal, this value is equal to 0.5. So plus Ke max, this is equal to Ke maximum 1. So in this first case, this value is equal to Ke1. So what is the Ke maximum is equal to how much here? So which implies Ke maximum 1 is equal to, say, what is the value here? 3, again minus of 0.5. What is the value is equal to, this one is equal to 2.5. So 2.5 electron volt. The maximum kinetic energy of the emitted photoelectrons is equal here. So this one is equal to 2.5 electron volt, okay? In the second case, So whenever here the photon energy is equal to 4 electron volt, so which is incident on this second metal. The second metal work function is equal to how much is given? 1.5 only here. So what is the value here? This is equal here to the 4. So which value is equal to 1.5 plus again Ke max. So Ke maximum 2. So which implies, so what is the Ke max equation here? So this Ke maximum 2 is equal, this is equal here to the 4 minus 1.5. Same, this value is also equal to 2.5 electron volt, 2.5. Again, next one, third point is equal here, third point. Again here the photon energy is equal to 5 electron volt. So 5 electron volt is equal here. So what is the work function of this third metal is equal here? So this value is equal to 2.5 plus Ke max, 2.5 plus Ke maximum 3. So what is the Ke maximum is equal to how much here? The Ke maximum 3 is equal to same. This 5 again, this is equal to minus 2.5. So 5 minus 2.5 is equal to 2.5 electron volt. So that means here in these three different cases, we got the maximum kinetic energy of the emitted photoelectrons only. So maximum kinetic energy of the emitted photoelectrons. Same, this is equal to 2.5, this also 2.5, this also 2.5. But what is the question is equal here? So what is the ratio of the maximum kinetic energy only? So what ratio is equal to how much here? So Ke maximum 1. Again, east Ke maximum 2. Again, next one is equal to here again Ke maximum 3 is equal to. So just imagine what the value is equal to here. 2.5 is to 2.5 is 2.5. So this value is equal to 1 is to 1 is to 1. So one simple question here. So you have to find out the ratio of the maximum kinetic energy, that is equal to 1 is to 1 is to 1. Next, sum, sodium, copper have frequencies 2.3 electron volt and 4.5 electron volt respectively. Then find the ratio of threshold wavelength. Then find the ratio of threshold wavelength. I wrote simply W naught means threshold wavelength. Then find the ratio of threshold wavelength, nearly, not exact here. So nearly value you have to find out. Here two metals are given. Have the frequencies is equal to 2.3 electron volt and 4.5 electron volt. So what is the, then find the ratio of the threshold wavelength is equal here. What is the equation here? This how the frequencies are given here. This is equal to 2.3 electron volt. So our work function equation W naught is equal here H nu naught. Shall we do this one here? Let's do it. Sodium and copper have the frequencies are given. That frequencies is equal to 2.3 electron volt and 4.5 electron volt. Then find the ratio of the threshold wavelength. That answer is nearly equal here, right? The options also here. So one is equal to 1 is to 2. And again second option is equal to 4 is to 1. And the third one is equal to 2 is to 1. Two is to 1. And again fourth one is equal, fourth 1 is to 4, 1 is to 4. Do this question, simple question here. Only one step answer here. We have to find out nearly value, not exactly. Again, next sum. The work function of photosensitive material is 4.0 electron volt. 4.0 electron volt. This longest wavelength, W elements longest wavelength of light, that can cause photon emission from the metal is, you have to find longest wavelength. What is the longest wavelength is equal here? The work function is equal to given, that work function is equal to 4 electron volt. 4.0 means 4 electron volt. 4 electron volt. This longest wavelength of the light that can cause photon emission from the metal is. Work function is equal to given. So what is the value is equal? W naught is equal H nu naught, or this is equal Hc by lambda naught. Shall you do the remaining solution here? So W naught is equal to Hc by lambda naught here. So in this question, W naught is equal to again which value is equal to electron volt one here, very simple one here. So whenever electron volt is given, that sum is very simple also here. And again W lambda naught is equal here. So lambda naught is equal to Hc by W naught. Here Hc is equal to how much? Well, this is equal here 12,400 electron volt. Again W naught is equal, this one is equal to 4 electron. Let's do this one here. This answer must be again angstrom unit one here. So 12,400 by 4. Okay, next one. I know, next one. A graph is drawn between stopping potential, you have to complete the stopping potential V naught. A graph is drawn between V naught, stopping potential V naught. This value is equal on y-axis, okay, y-axis, and incident light frequency. This one is equal to nu in the bracket x-axis here. Already I told this application also here, fifth application. And again this is the relation between the stopping potential and frequency one here. In that value, so here the stopping potential value is taken on y-axis only, and I get external frequency of incident light on x-axis here. Same that question is given here. So now the incident, the intercept OA x-axis given 0.5 into 10 to the power 15 hertz. So just imagine here what is the value of this 0.5 into 10 to the power 15. If you know this value here, the sum is very simple and very easy one here. Your thinking capacity only what is the value of this 0.5 into 10 to the power 15 hertz on here. Find the kinetic energy of photoelectron emitted from the metal when energy of incident photon is 5 electron volt. One of the most important questions, this question is given frequently like an AIPMD question here. If you know this application, if you know this relation between this incident light frequency and stopping potential, like this sum is very simple over here, very simple also here. So what is the question here? A graph is drawn between the V0. So V0 is equal to stopping potential. This stopping potential is taken on y-axis. So this also given in the question over here. Very simple also, question given y-axis one here. And again, incident light frequency, this is equal to nu. So this also given on x-axis over here. Okay, that means 20% of the solution is given in the question over here. 20% is completed here. Since here the V0 value is taken on y-axis over here, frequency value is taken on x-axis over. That also given in the question here. And again, next one, the intercept OA x-axis is given by, that value is equal to 0.5 into 10 to the power 15 hertz. Okay. So if you know this value here, the sum is equal to very simple. So next, what is the answer here? What is the question here? Find the kinetic energy of the photoelectrons. Find the kinetic energy of the photoelectrons emitted from the metal surface when energy of incident photon is equal to 5 electron volt. So what is the kinetic energy is equal to how much here? So what is the kinetic energy equation? This energy E is equal to I will add solution this above only, above the question. First you have to draw this graph. So in this case here the stopping potential value is taken on x-axis here. This one is equal to V0. And next one, incident light frequency on y-axis over here. So what is the graph position is equal, this is one straight line, okay, this point. So now extend this line. So this point is equal to O, this is equal to A, this one is equal to B, okay, OA, OB. In the last class also given here 3 points in this graph also here. So what is the first 2 point is equal here? Slope. So what is slope is equal to how much here? The slope M is equal to slope, M is equal, this one is equal to H by E. The value should be remain same for all metals only, H by should remain constant here, okay? Again, next second one is equal, second point is X intercept is equal here. So X intercept is equal to OA. So tell me what is the value of OA is equal here? X intercept is equal, this one is equal to threshold frequency, this is equal to nu naught, okay? This point is important one, okay? Threshold frequency is equal to nu naught. Again, third point is equal to what is the Y intercept is equal, this one is equal to OB. So OB is equal to how much? This is equal to OB. So OB is what is equal, this is equal here so H nu naught by E or W naught by E. This is equal to W naught by E. Okay, so if you know this application here, if you know this graph, like a remaining solution very simple one here. So in this question here, what is second point is equal, the intercept OA x-axis is given by, so 0.5 into 10 to the power 15 hertz. So what is the value of this one is equal to how much here? Please see the graph also here. OA is equal to nu naught. So that means here the threshold frequency is given only. So those students got this point here, remaining some very simple one here. This threshold frequency is equals given. So this nu naught is equals to 0.5 into 10 to the power 15 hertz. Almost as 50-60% sum completed here. 20% the question only given here. Since here so V naught is equals on y axis one here, again nu again on x axis only. Again remaining is equals to OA is equal, this one is equal to threshold frequency. So OA is equal to threshold frequency. This one is equal to threshold frequency. So this one is equal to nu naught. Okay. Again, now again, so nu naught is equal to 0.5 into 10 to the power 15 hertz. So remaining, what is the question here? Find the kinetic energy of the photoelectrons is equal here. So what is kinetic energy question here? This energy is equal to W naught plus kinetic energy Ke. Shall you do the remaining solution here? So what is the Ke max? What is the equation here? Ke max is equal here. So E minus W naught. Again, some students getting doubt also. So in this question, E is equal to given here. So this is equal to 5 electron volt given. So E is equal to 5 electron volt. So W naught value is not given, sir, here. So simply what is W naught equation here? So W naught is equal to HC or H, this is H nu naught. HC by lambda naught or this H nu naught, okay? So H is equal to how much? This is equal to here the 6.63 into 10 to the power of minus 34. Again, nu naught is equal to 0.5 into 10 to the power of 15 hertz. Again, next one more twisting here, So this work done is, this value is equal to joules on here. But again here this energy is equal electron volt on here. So now we have to convert this joules into electron volt only. This point is very important one. So total again some twisting here only. Some students simply doing so this is equal joules, this electron volt here. They are forgetting that units here, so not getting answer. Simply here this is equals electron volt is equals to given here. So this one is equal again joules also here. So W naught is equal H into nu naught 6.63 into 10 to the power minus 34 again into 0.5 10 to the power 15 joules. Okay. So now we have to convert it electron volt. Okay. So 1 electron volt is equal what is the value here? So 1.6 into 10 to the power minus 19 joules. So 1 joule is equal to how much here? 1 by 1.6 into 10 to the power minus 19 electron volt. Okay. So first you have to find out this value is equal here 6.63 into 10 to the power minus 34 into 0.5 into 10 to the power 15. Again joules to electron volt. So 1 joule is equal to, I am rubbing this question also here. Okay. So this is equal, a graph is drawn between V naught y axis and incident light x axis. Okay. I am going to rub this one here. So now what value is equal here? This is equal again 6.63 into 10 power minus 34. Again 0.5 into 10 to the power 15. Again joules. So you have to convert into electron volt. So 1 joule is equal to 1 by 1.6 into 1.6 into so 10 to the power minus 19 electron volt. Please find out this value is equal here. So let's do the sum. Hello, this one is equal here the first one 6.63 by 1.6 nearly, so 1.6 into for how much near 6 point something 6.64 here nearly cancel here. Okay, this 16 1 just 16 4 just 64 nearly something. Okay, again next one is equal 4 into 0.5 is equal how much here? This is equal 20 2. So 4 into 0.2 10 power minus 34 plus 15 minus 9. What value is equal here? See, cancel on here. Okay, since here minus 34 again plus 15 is equal minus 19. This minus 19 again by again 10 power minus 19 is cancelled on here. So nearly this one is equal, this is equal, nearly value is equal here 2 point something or 2 electron volt. 2.9? 2.07 electron volt, okay? Or simply this value is equal to also here, okay? Nearly equal to also here. So what is that equation here? This Ke max is equal here. So E minus W, E is equal to 5. And this one is equal to 2.07. Or this is nearly 2 also enough over here. This is equal to, so 2.0 electron volt. This is equal to 3 electron volt. Options are given 3, 4, 5, 6 something over here. So nearly value here. No need of this exact value here. Just nearly equal to electron volt here. 2 electron volt. 2 electron volt. Okay, next one. Again. Next question. Same model here. Note. Same V0 is equal to on y-axis here, like nu is equal on x-axis here. So 1 is equal to nu naught 1, this is equal here nu naught 2. So one is a metal here, this one is equal to metal B. So this one is equal to W naught by E1, so W naught by E2. I'll find out nearly values, no need of exactly also here, depends on the options. Note down. The graph shows variation of stopping potential V0 with the frequency of incident light, for two photosensitive metals, metals A and B. Which one of two has higher value of work function? Please draw the graph also here. Just once we did same this model here. A and B again two metals are given, that work functions again here are given W1 1, W0 again 2, A and B. This variation of the stopping potential is equal to V0 and frequency is equal to nu of incident light. For the two sensitive metals A and B, two sensitive metals A and B. So which one of two higher values of the work function is equal here? So what is the maximum work function for A or work function for B is equal to maximum is equal here? What slope is equal, what is value here? This first A graph slope is equal here. Again, this is equal to B slope is equal here. Slope, what is that value here? Slope is equal here. So this value is equal to H by E. The value should remain same over here. For all metals here, the slope should remain same only. So H by E should remain constant. Okay? Again, next one. This threshold frequency is equal to nu naught 1. This threshold frequency is equal to nu naught 2. So which value is more here? Nu naught 1 or nu naught 2? Again, nu naught 1 and nu naught 2 here. So nu naught 2 is a more value on here. This threshold frequency is equal to more means here. So what is the work function is equal here? So work function W, what is it equal? W naught is equal, this one is equal to H nu naught. Here the nu naught 1 is more than, nu naught 1 is equal, nu naught A is more than nu naught B only here. That means here the B metal have the more again work function. So this answer is equal to B metal. So why B metal means here the, since here the, so this A metal is equal to nu naught 1, this threshold frequency here. Then again next one, this is equal, nu naught 2 is equal to threshold frequency B only here. So which value is more here? So nu naught 1 is greater than nu naught 2 only here. The threshold frequency of the first metal, this one, nu naught 1, again nu naught 1, again now this is a nu naught, okay? So what if this is equal to nu naught 2 is greater than nu naught 1. So this one is equal here, the nu naught 2 is equal, this one is equal to B. So again greater than nu naught A only here, nu naught B is greater than nu naught A. The threshold frequency of the B metal is more. Threshold frequency B metal is equal to more means what happens here? So work function, this is equal here W. So W of B metal is greater than W of A. So hence, so work function of the B metal is more than again A metal. Okay, thank you all of you.